So let's get started. I'd like to say good morning. Welcome to everyone to this Energy Egypt's first webinar. It's brought to us by Egypt Oil and Gas Publications. I hope everybody is doing well as we come to the end of another week. I'm joined on the panel today by Mr. Marco Arma, who's the Field Operations Manager of Shawcor, Mr. Jonathan Gibson, the VP for Business Development, and Dr. Khaled Mamour, Regional Sales Manager. We also have Mr. Amr Tawfiq, who is the Maintenance Manager for West Bakr and Petrodara oil companies here in the Eastern and Western deserts. So the format today is we're going to have a quick show from Shawcor, after which we'll have a quick presentation by Mr. Amr Tawfiq on a project that was actually done here in Egypt. And then we're going to end up with a very quick questions and answers session. If anybody does have questions that they want to put to the panel, you will find here on the Zoom screen on the bottom middle section something called a Q&A, where you can actually type in your questions. They will come to me and I would feed them to the panel. So please do participate, do ask any questions, any concerns you have, and we'll try and cover everything today in as quick as time as possible. So now, without any further ado, I'm going to hand over to Shawcor. If you can please take away.
Thank you, Aidan. Good morning all, and welcome to the webinar. I would like to start by thanking all the people involved in organizing it, especially our partner Energy Egypt, Mohammed, Aidan, Daria, Tamara, thank you. I'm hoping that our guests find it useful and beneficial. Today, we'll talk about composite pipes and their economic benefits relative to carbon steel and stainless steel pipes. And to do so, we're going to go through a number of slides, of course. We will be covering the technology in a generic way, then go through its differences with steel and subsequent advantages and cost savings for users. Finally, we'll tell you about a specific case in Egypt, for which we have the pleasure of welcoming engineer Amr Tawfiq of West Bakr, who has kindly accepted to talk about his experience with this technology in general and flex pipe, which is Shawcor's pipe in particular. Before we get into the specifics of the pipe itself, let me tell you quickly about composites. So a composite material is one that combines two different materials, leading to one with a superior performance. Examples of this are in aircraft, where there is a need for strength, lightness, and flexibility, where composites are widely used. Composites started with Chinese bows during the Chang dynasty in 1700 BC, which combined the strength of the animal horn with the flexibility of the tendon. These were laminated together to get a bow that flexes more than others without breaking, leading to much longer reach when the arrow is fired. In our case, HDPE, which is high density polyethylene, inner and outer jackets, are known to be inert and have good chemical resistance, are good for applications with significant amounts of hydrogen sulfide or carbon dioxide, and are flexible. The HDPE is combined with a reinforcement layer, which generally either aramid, steel, or fiberglass, to result in a pipe with superior performance, handling temperature, pressure, aggressive contents such as sulfur or carbon dioxide, and other criteria. These pipes are known as RTP, reinforced thermoplastic pipes, designed to meet requirements of API 15S standard. This standard can be made available if required. The spoolable pipes come in reels of 300 meters to 2,000 meters, depending on diameter, consequently requiring less connectors relative to carbon steel pipes. Right, how do we connect the ends of these type of pipes? No welding is involved, as you know, because it's not made of steel. So some suppliers use threaded compression and others use hydraulic compression to connect the pipes. And pipe suppliers usually provide the connection equipment and training of personnel to use it, as well as assistance with using it to install the equipment. The fittings are in corrosion-resistant coated metal or made from corrosion-resistant alloy. Together with the pipe, they form a very good corrosion-resistant product. Right. Let's look at the applications. Where are these pipes used? Applications for this technology are diverse, as known through Shawcor's experience and installation base. The most common use is in oil fields, as oil and gas gathering lines, water injection, and wastewater. Due to the inert nature of the inner layer of HDPE, the pipe can handle many different types of fluids. To mention some of the applications that might be of interest, for example, aggressive gases, such as carbon dioxide or sulfur, zero flaring, liner pull for rehabilitation of existing pipelines. For example, you have a pipeline that is defective and you want to replace it. Instead of replacing it and trench and take the pipe out, what you do is just pull a composite pipe through it. Temporary lines, and of course these pipes as well, one of the major advantages is that they could be reused. May I now hand over to my colleague Marco Armas, who will tell you about the installation side and the cost savings during that phase. Over to you, Marco.
Thank you, Khaled. Good morning, everybody. In order to highlight the advantages of installing a spoolable composite, I would like to review with you a typical steel pipe installation process. The life cycles start with sourcing the pipe from a manufacturer, getting an external protective coating, and transporting the pipe to a warehouse or distributor. The site is cleared and graded before the pipe is deployed. Field bends also need to be performed, and the pipe needs to be aligned and prepared before it is welded. Welding inspections and field apply coatings need to be performed before the pipe is lowered. After that, the line is commissioned and handled to operations. Let's compare now, this is the full steel pipe line life cycles. Let's compare now this one with composite pipe life cycle. The composite installation reduces or eliminates several processes of the typical steel project. Processes in this slide within the gold box are simplified, and the gray boxes are removed entirely. Pipe transport is typically simplified as the pipe goes directly from the manufacturer to the installation site, minimizing trucking and storage costs. Clearing and grading is faster and causes less disruption due to minimizing workspaces along the route. A spoolable pipe can be deployed faster than steel, and it can be safely done with no large, expensive equipment. Bending, inspections, and field coatings are typically eliminated from the construction process. Welding is reduced and is typically only required at the end connections, just in case that you are not using a flange connection. The smaller right-of-way and the flexible nature of composite pipe installation reduces the time and cost of trenching, backfilling, and cleanup. Finally, the operations and maintenance requirements for composite lines are reduced due to the corrosion-resistant materials. Generally, a composite product can be installed 20 to 30% faster, which will save you money on the installation and reduce the time to the first oil. This, of course, will depend on your project-specific conditions. For example, in the Bolivian jungle, a 10 kilometers, 4-inch line was scheduled to be completed in 6 months on steel. The same contractor using Shawcor composite pipe installed the line in just 40 days. We are comparing 6 months against 40 days. Later, Amer will explain the West Bakr experience in Egypt through a case study. A composite installation can be done with less manpower and less equipment than equivalent steel pipeline. The composite lines requires less trucking. For example, 1.8 kilometers of 4-inch pipe can be shipped on a single truck, and only one excavator is required for the installation. The material can be deployed with trucks and trailers, reducing the requirement for heavy equipment. Total manpower is reduced from 10 people on average on a steel line to 4 on the composite line. Fewer specialized workers are required. And the installation is less labor-intensive overall. An additional person may be required to install the connectors or fittings, but that cost can be minimized through planning or training your local contractor. Currently in Egypt, we have a very good contractor that is totally trained. X-ray inspection is not required on the composite products, which can also be brought to surface without steel risers. Demobilization is also simplified due to less equipment being required for the install. Let's chat now about deployment methods. Spoolable pipes are very robust and can be installed using a wide variety of techniques in nearly all terrains. Our pipes have been installed near the Arctic, in the desert, in wetlands, and in the jungle. Trenching is the most common installation method for spoolable composite, and practically the installation can go as fast as the ditch can be opened or stay open. Surface lines are popular due to the low cost and the short time required to install the pipeline. It is possible to deploy and install composite pipe up to 50% faster than a steel pipe. Plowing and chain ditching are very successful in areas with little pipeline infrastructure due to the low impact and the installation pace. It is possible to install up to 2 or 4 kilometers per day using these techniques, which are very popular in Canada and Australia. Horizontal drilling or boring has typically been used for road crossings or terrain crossings, but it has become a preferred method for some users due to the minimal environmental impact. In most applications, it's more reasonable to pull 2 full reels of pipe, and longer lengths have been achieved under good conditions. Liner pulls are also considered as an easy solution when there is an existing failed steel line. Let's chat about total project cost. Using a spoolable composite pipe can decrease the overall project cost between 20 and 25%. This is a conservative estimate based on averaging a variety of conditions. A well-planned installation with an experienced contractor could likely beat this estimate. Significant costs are realized during the installation. The reduced crew size, lower equipment size, and the fast installation pace create a very efficient installation. This benefit can lead to up to 30% lower installation cost compared with steel. Currently, a spoolable composite may require a large upfront investment compared to steel, but once you consider the total project cost, there are significant savings when using a spoolable composite. For example, India is a region with very cheap labor and low steel pipe prices, but it's still economical to use a spoolable product due to the installation efficiencies. Let's chat about corrosion resistance. Besides the installation's advantages, a spoolable composite can also save money during the operating life. Due to the corrosion resistance, it's possible to reduce or eliminate the use of chemical corrosion inhibitors. For a typical gathering system, this could result between $20,000 and $40,000 annual cost savings. An operator with a large composite installation base could be saving over $500,000 in chemical costs per year. In addition to the chemical cost savings, composite products can also eliminate the requirement to create or maintain cathodic protection system. Of course, that will depend on your regulatory entities or local regulatory entities. Let's chat about the liner material. Most spoolable composites have an HDPE inner liner. These materials can reduce the initial buildup of scales or paraffins, which leads to reduced pigging requirements. The smoothness of the liner material also leads to higher flow rates and lower pumping costs compared to an equivalent steel pipe. Steel can also become rougher over time, which leads to increased pumping costs and pressure. The chart on the right corner compares the flow rates for composite pipe and a new steel pipe. Keep in mind that as the steel line ages and corrodes, the pressure drop through that line could increase between 50 and 100%. That is not going to happen with a composite line. Here, we can see a summary of the testing used to design and qualify Shockwave spoolable product as per API 15S. On the design pressure capability of one of the most important tests is the regression pressure testing. In the application performance, we can highlight the aromatic exposure, the rapid decompression testing, and the UV exposure or resistance. On the installation side, one of the most important for us, of course, is the impact resistance test. I will be available for questions at the end of the presentation. Khaled will take it over from here. Thank you so much.
Next slide. Thank you. Right, so a bit about Shawcor's flex pipe. So Shawcor's flex pipe has been around for over 18 years, during which we have supplied over 40,000 kilometers of pipe and over 180,000 fittings to clients all over the world. We have supplied some of the largest oil companies in the world, including Saudi Aramco, Chevron, Exxon, and Shell. We have supplied over 1,000 kilometers in the Middle East with installations in Saudi Arabia, UAE, Kuwait, Iraq, Oman, and others to follow shortly. Some clients have standardized on our technology and products. We pride ourselves on our customer service. Feedback from existing clients reinforces that all the time. Recently, we have supplied 26 kilometers to West Bakr in Egypt. Sapesco did a very good job at installing the pipe and are trained and have the required equipment in country to do more as and when required. May I now let engineer Amr Tawfiq of West Bakr tell you more about this specific installation. Over to you, Amr. Thank you.
Thank you, Khalid. Thank you, Eden. Thank you, Marco. Thank you for attending today's webinar session discussion, the economic of spoolable composite pipe compared to steel. I hope you found it to be a valuable use of your time. Let's start with the project overview. West Bakr fields are in the eastern desert of Egypt. The company has 3 oil fields, K, M, and H, which started production in 1980. We have 49 pumping oil wells. Gathering network are all internally bare carbon steel, which was poorly protected by corrosion inhibitor chemical. The flow lines are bare carbon steel pipes that suffered from frequent corrosion failures in recent years due to increasing water cuts, leading to spills and lost production for pipe repairs. A fault failure analysis was done using corroded sample by the Mining Studies and Research Center and the Central Metallurgical Research and Development Institute of Cairo University. The conclusion was corrosion potential of the produced fluid is high due to considerable amount of carbon dioxide and oxygen combined with high quantities of water. This ensures continuous presence of water phase in contact with the bare internal carbon steel pipe surface. So a decision was taken to replace and install new flow lines with pipe having an internal corrosion barrier. We have many alternatives, but we selected the spoolable composite pipe. The project budget was $1,250,000 US. The awarding date was the 10th of October 2019. The completion date was in the 10th of February 2020. The main contractor was Energy Egypt, and the subcontractors were Shawpur for material supply and supervision, Sabesco for installation. Let's go through the measurable impacts of this project. No more oil spills, which is considered as a direct environmental impact. No more production losses, which is a cost impact. No lost time for workers for pipe repairs. Smooth production and operations, saving the cost of using production inhibitors in terms of chemicals, pumps, corrosion monitoring system, with about $50,000 US per year, saving the cost of replaceable parts of pipe repairs that require rental equipment to perform the repair jobs and spilled oil recovery, saving the cost and time of installation by 30 to 40% compared to carbon steel pipes. Finally, the quality of delivery of this project. The project was completed within 4 months, starting from the effects of award till commissioning and startup within the approved budget. Project deliverables are matching the desired objectives. Challenges that we faced were the execution duration of installation and tie-in of around 25 kilometers of spoolable pipes and 20 hydro tests. The contractor managed to deal with this by the following: safe installation where zero lost time incident recorded, professional execution team and supervision, installation schedule and procedure commitment, proper installation equipment and tools, excellent installation progress reporting, and high-level managerial follow-up and collaboration. Finally, I'd like to thank you. I'd like to thank my West Bakr and Petrodara top management for their unlimited support. I'd like to thank all West Bakr teams for their efforts to perform this job. I'd like to thank my partners in this project, Shawpur, Energy Egypt, and Sabesco for their professional project. Thank you very much.
Thank you, I'd also like to thank West Bakr myself for taking this leap into what is a new technology here in Egypt. And now I'd like to pass back to Dr. Khaled, please.
Thank you, Aidan. Just a quick summary and a takeaway message. Shawcor's Composite spoolable pipe, flex pipe, is a very good solution for complete avoidance of corrosion and its impact on carbon steel pipes. Cost efficient for installation, less equipment, people, and time. No requirement for corrosion inhibitors, cathodic protection, or maintenance. Reusable under certain conditions. Global and regional track record with major integrated oil companies and national oil companies. Existing installation in Egypt, West Bakr. Trained and equipped installer in Egypt, Sabesco. And you have local support through Energy Egypt and global support through Shawcor. We're open for business. Thank you.
Thank you, Dr. Khaled. So I think now just to wrap things up, I'm going to jump to the questions and answer session. So we've got some questions coming out. I've also been emailed some questions. First question we have, the suitability of flex pipe on something like a firefighting line. Would it be suitable for a firefighting line? I guess the question would revolve around whether or not the line is flammable. I don't know.
Marco, do you want to handle that?
Yeah, but did you mean the water for transportation, water for fire emergencies, or is the pipe is fire resistant itself?
And the question itself was, is it suitable for application of firefighting lines? I mean, obviously for transferring water, it's very suitable.
Yeah, it's very suitable. Yeah, we just need to the application review with the operating parameters, and we will recommend to you based on the type of pump. You can use flex pipe or flex core products.
Okay.
If I may just add to that, sorry.
Yeah.
Just for peace of mind of potential users, what we tend to do, what we do usually, and all the time really, is to submit an application review to the user. And from the information that they supply to us, we will make sure that the pipe is suitable for the product or not, for the application or not.
Okay.
Okay.
We have two very similar questions talking about the sizes. What's the maximum available pipe size, and what's the different dimensions of the pipe size? So let's just jump in. What's the maximum available pipe size?
It's a 6-inch nominal
Yeah.
diameter. It's in that.
Okay.
It's in the one of the slides.
Yeah.
Looking for that slide specifically, the way that we remind the participants.
I think it's the third slide.
Okay. We've also been asked if this product is suitable for offshore installations.
We have a product that was installed on shallow waters, but is not recommended for offshore applications, just onshore applications or shallow waters when we are talking about lakes or swamps. We have a 2-inch product that is anti-buoyance we can use on those applications, but not offshore.
Yeah, I mean, one of the things that might be of interest here in Egypt is that we have what we refer to as sabkha. It's a type of, I guess, quicksand in the Western Desert and even in the Eastern Desert. It would be suitable in that environment. So
Yes.
It's slightly corrosive environment.
In that case, yes.
Okay, that's good. Another question came in relating to the installation process and how it goes in terms of safety, cooperation between the various parties, Shawcross, the supplier, the JV, and obviously then Sabesco as the approved installation company. Did we have any concerns, any issues on the installation in West Bakr? And either Marco or Amr, you can answer that one.
No, not really. The collaboration was very smooth, actually, and very professional. We have huge support from the West Bakr field team, the field operations and integrity team. They were shoulder to shoulder with us all the time. Sapesco is a very professional contractor. We had been working with many contractors around the world, and we have Sapesco in a very good concept now after the installation. And we didn't have any kind of HSE or environmental issues during the installation. And we spent, if I'm not wrong, 35 days continuous on the field and no issues, including hydro tests, deployment, inspection, installation. I think that it was a very, very good experience.
Okay. The person that asked the question on the firefighting has come back. The line is used to take seawater to be used in firefighting. And the question was specifically, is it fire retardant?
Oh, yes, the pipe is going to be fire retardant, but we have some testing that we can share that where we apply like what we call a bush fire. Then we can share that information. We can withstand bush fire.
Yeah, I would like to say to anyone that's joined us today, if you have any questions, Energy Egypt are here. Please do contact us and we will do our best to get you whatever information we can from Shawcross to help you understand this product.
Yeah.
Another question just came in, is the difference between composite pipe and coiled tubing pipelines?
Well, coiled tubing is considered a metallic pipe, and it's good for downhole applications when you are testing a well or even for producing from a well temporarily. And composite pipe or the concept that we want to explain today as RTP is not designed for downhole applications, at least the spoolable composite pipe that we manufacture. I know that GRE pipe can be used, it's a composite pipe that can be used for downhole application, but this is not our case.
Okay. One of the questions that was emailed in relates to the different types of artificial lift systems we have and how the composite pipe deals with the differences between the pump jacks, PCPs, ESPs, and especially the cyclical nature of, let's say, some of the pumps.
Yeah, this is a very good question. Our products are flex pipe and flex pipe HYPE 10 are recommended for applications that have electrosubmersible pumps, progressive cavity pumps, horizontal pumps like multi-stage centrifugal pumps, and of course, a gas compressor on gas applications. But we have certain limitations when we are talking about what we call duplex or triplex pumps, okay? Then in that case, we need to analyze the operating parameters, and maybe we can recommend, instead of FlexPi or FlexPi High 10, FlexCore, that is our product with a steel reinforcement that will be a very good or good match for applications with pump jack that have a high pressure, or with longer duplex or triplex pump. That's a very good question.
Okay. And last question we've got in, I think, relates to erosion. Now, what kind of, environments would you not be using this product in, I guess?
Well, we had been testing our pipe, and in collaboration with some universities in Canada, to provide a specific answer to this one. But what we can say at this point is that our pipe have a less rugosity than a steel pipe, will be affected depending of the type of grain, velocity of the fluid, and size of the grains. We had seen erosion reduces between 20% and 50% compared with the steel. And
right.
But that would depend, as we said, of too many different factors.
Okay.
And it's important to mention what we saw in the presentation, that a steel pipe with time and aging is going to increase the problem with erosion. Good question, though.
Okay, so guys, listen, that really is the end of the questions that we've had for today. Okay, I think it's also the end of the presentation. I'd like to thank Shawcor for making this presentation, and I'd also like to thank everyone who joined in to participate.
Just as a reminder, we can answer all the other questions that remain by email.
Yeah.
At earliest convenience. Okay. Thank you, Aidan.
Yeah. Okay. So guys, thank you very much for participating today, and thank you to everyone that joined us to watch this. As I said, if you have any other questions, please do contact us here at Energy Egypt for Oil and Gas Services, and we will forward all of the technical questions on to Shawcor, try and get back to you individually. I would also suggest, if you're an EGPC company, go talk to West Bakr. Mr. Omar Tawfiq is a good friend.
Thank
and
you.
I'm sure he'd be more than happy to share his experiences with you. Omar, Dandakai Mashakal.
Thank you, Eden. Thank you to you.
Okay, guys. And that's it for today. Khaled, anything you want to say in conclusion?
I think just thanking everyone, and please feel free to contact any of the guys on the panel with your questions and clarifications, if any.
Amen. Okay, gentlemen.
Thank you.
Thank you very much, and look forward to the next webinar from Energy Egypt. Thank you.